Welcome back to Math Dogs. If you're new to the channel, please comment, like, and subscribe. If you have any questions, please comment down below. Today's topic is radicals. We have 10 examples dealing with simplifying, radical operations, and solving radical equations. Remember, we believe math is better with your dog, so call your pups. Let's get started. Problem number 63 is simplifying radicals. It says the square root of 40. So it helps if you have your square numbers memorized. If you don't, we're going to list a couple. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, etc. And we want to break this square root up using the product property for square roots into two factors. In the first square root factor, we're going to put all the perfect squares that are factors. And in the second one, we're going to put everything else. And so I have to think about the factors of 40 looking at my square numbers. Are one of these square numbers a factor of 40? And the answer is yes. There's a perfect square factor of 4 times everything else would be 10. The square root of 4 is 2. All I can do is express the other, and so my answer would be 2 times the square root of 10. Problem number 64 is also simplifying radicals. It says the square root of 32x to the 5th, y to the 6th, z. So again, I'm going to use the product property for radicals, and I'm going to break it into perfect factors and non-perfect square factors. So perfect square factors here, everything else here. So if I think about my number 32, I know that there's a perfect square number 16 times 2. So 16 will go in the perfect square radical, 2 will be in the other. If I look at x to the 5th, any even power is a perfect square. So the largest even number before I get to 5 would be 4. So I would have x to the 4th in the perfect part, and I would have an x left over to get to 5. Now I'm going to look at the y to the 6th. Well, 6th is an even number, so y to the 6th is a perfect square factor. Then I'm going to look at z. Z, there's a hidden 1 right here. To the first, I can't even get to an even number, so that would be in the other radical. Now I can take the square root of the perfect radical. The square root of 16 is 4. The square root of x to the 4th, I take 4 and divide it by 2 or cut it in half, which would be x squared. And y to the 6th, again 6 divided by 2 or cut 6 in half, and I would get y to the 3rd. My other radical, all I can do is express it as 2xz. And so my answer would be 4x squared y to the 3rd times the square root of 2xz. Problem number 65 is again simplifying radicals. It says the cube root of 16a to the 4th, b to the 7th, c to the 3rd. So we're going to use the product property one more time, and we're going to put our perfect cube numbers in the first one times all of our others. If you have your perfect cube numbers memorized, it makes the problem easier. If not, we'll list some. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64, etc. And so now I need to think about the number 16. Looking at my list of perfect cubes, is there a factor of 16 that's in my list? And the answer is yes, there's 8. So I will put 8 in the perfect cubes times 2 in the other. Now I'm going to look at a to the 4th. This time we're not going to look for even numbers, we're going to look for multiples of 3. 3, 6, 9, 12, etc. I need the largest multiple of 3 before I get to 4. That would be 3. So I would have a cubed in the perfect cube root and a in the other to get to 4. Now I'm going to look at the b factor. I have b to the 7th. What's the largest multiple of 3 before I get to 7? And that would be 6. So I would have b to the 6th in the perfect cube and b in the other. Now I'm going to look at c. Well, 3 is a multiple of 3, so c to the 3rd is perfect. Now I need to take the cube root of 8a cubed b to the 6th, c to the 3rd. So the cube root of 8 is 2. The cube root of a to the 3rd, 3 divided by 3 is 1, so that would be a. Now I'm going to look at b to the 6th. 6 divided by 3 is 2, so that would be b squared. And then I'll look at c. 3 divided by 3 is 1, so that would be c. My other, I just have to express as the cube root of 2ab. And so my answer would be 2ab squared c times the cube root of 2ab. Problem number 66 is radical and exponent forms. It says write in exponent form the square root of 5. So if I have the square root of 5 and I add in the hidden numbers, there's a 2 here and a 1 here. To write it in exponent form, I'm going to put the 1 in the numerator and the 2 in the denominator. Or what I say, raise the root. So that would be 5 to the 1/2 power. Problem number 67 is again radical and exponent forms. It says write in exponent form the cube root of x squared. So I have the cube root of x squared, and remember fractional exponents indicate roots. So 2 will go in the numerator, 3 will go in the denominator, or again, I want to raise the root. So I have x to the 2/3 power. Problem number 68 is radical and exponent forms. It says write in radical form m to the 1/3. So this time I'm going to take what's written in exponent form and write it in radical form. So if I think about raise the root, I'm going to raise m to the first power inside, and then the root would be 3. So I would get the cube root of m. Problem number 69 is radical and exponent forms. It says write in radical form n to the 4/5. So I have n to the 4/5 as a fractional exponent, and I want to write that with a radical. Again, I'm going to raise the root. So n to the 4th raised to the 4th, and the root would be 5. So my answer would be the 5th root of n to the 4th. Problem number 70 is adding and subtracting radicals. It says the square root of 27 plus the square root of 18 minus the square root of 12 plus the square root of 32. So first we're going to have to simplify all 4 of these radical terms, just like we did in previous problems. First we'll look at the square root of 27. We're going to use the product property and break that up into perfect square factors times other. There is a perfect square factor of 9 times 3. Now we'll look at the square root of 18 and we'll do the same thing. Perfect square factor times others. Again, there's a perfect square factor of 9. This time it's times 2. Minus, same thing with the square root of 12. Perfect square factor times others. We have a perfect square factor of 4 times the other would be 3. And last, we'll look at the square root of 32. Perfect square factor times other, that would be 16 times 2. Now we'll go ahead and simplify each of the perfect squares. The square root of 9 is 3 times the square root of 3. All I can do is express the square root. Plus, again, the square root of 9 is 3 times the square root of 2. Minus, the square root of 4 is 2 times the square root of 3. Plus, the square root of 16 is 4 times the square root of 2. Now we can go ahead and add and subtract. It's very similar to combining like terms. Just like we could only add variables with exponents that were the same, we can only add radicals that are the same. So I would have 3 times the square root of 3 minus 2 times the square root of 3, or 3 square roots of 3 minus 2 square roots of 3 would be 1 square root of 3. And I don't need to write the 1 in front. That's a hidden 1 in math. I also have 3 times the square root of 2 plus 4 times the square root of 2. Or we could say it 3 square roots of 2 plus 4 square roots of 2 would be 7 square roots of 2. And so my answer would be the square root of 3 plus 7 times the square root of 2. Problem number 71 is solving radical equations. It says the square root of x minus 3 equals 5. So first I have to make sure my radical is isolated or all by itself on one side of the equal sign, which it is. To undo the square root, we're going to square it. And since I squared the left side to keep the equation in balance, I also have to square the right side. Taking a square root and squaring are opposite operations, or as some people say, they cancel one another out, and that will leave me with x minus 3. On the right side, 5 squared is 25. And now I have a very basic equation. I will add 3 to both sides to solve. Negative 3 plus 3 is 0, 0 plus x is x, and 25 plus 3 is 28. When I have radical equations, I do have to check to make sure that it comes out true. So I'm going to put 28 back into the original problem where x is and see if I get a true statement. So 28 minus 3 is 25. The square root of 25 has to equal 5, and 5 equals 5. So that's true. So my answer would be x equals 28. Problem number 72 is also solving radical equations. It says the square root of 3x minus 2 equals x. So first I'm going to make sure that my radical is all by itself on one side of the equal sign, which it is. To undo the square root, I'm going to square it, and since I squared the left side, I also have to square the right side. So the square root and the square undo one another, giving me 3x minus 2. On the right side, when I square x, I get x squared. All I can do is express it. Since I have a squared, I know it's a quadratic. To solve a quadratic, I'll have to set one side equal to 0. I'm going to set the left side equal to 0 so that my leading x squared term remains positive. So I would subtract 3x and add 2 to both sides of the equation. 3x minus 3x is 0. Negative 2 plus 2 is 0, so my left side is 0. On the right side, x squared minus 3x plus 2, they're not like terms, so all I can do is express that trinomial. Now I will factor. So I will factor the trinomial into two binomials. X squared will break into x times x, and I will need two factors of 2 that add up to 3. That would be 2 and 1. Both signs in the binomials will be identical because it has to multiply to a positive, and they will both be negative signs. Now I'm going to set each factor. Case 1, what if x minus 2 were the 0? Then x would equal 2. Case 2, what if x minus 1 were the 0? Then x would equal 1. Remember, with radicals, I have to go back and check. So the square root of 3 times 2 minus 2 has to equal 2. So I substituted 2 for the x in the original equation. 3 times 2 is 6. 6 minus 2 is 4. Does the square root of 4 equal 2? And the answer is yes. So x equals 2 is definitely one of my answers. Now we'll check 1. The square root of 3 times 1 minus 2 has to equal 1. Again, I just substituted the 1 for the x in the original problem. 3 times 1 is 3. 3 minus 2 is 1. Does the square root of 1 equal 1? And the answer is yes. So x equals 1 is also an answer. So my two answers would be x equals 2 and x equals 1. So that's it. 10 examples of radicals solved step by step. Keep working hard. We know you can do this if you try. Don't ever give up on it. Keep watching videos and keep learning. And as we say at Math Dogs, you got this.